Hey guys, welcome back to this problem. Now we're going to solve a coding interview problem, minimum domino rotations for equal row. This is the most asked question by Google in 2020. In a row of dominoes, AI and BI represent the top and bottom halves of the ith domino. A domino is a tile with two numbers from 1 to 6, one on each half of the tile. We may rotate the ith domino so that AI and BI swap values. We have to return the minimum number of rotations so that all the values in A are the same or all the values in B are the same. If it cannot be done, then we have to return -1. For example, if we are given this two array A and B, here the same indices represent a tile that contains two numbers, top and bottom, 2 and 5. Now our goal is to do the minimum number of rotations so that the values of A are the same or the values of B are the same. For these two given array A and B, they are represented like this. Here if we do a rotation in between 1 and 2 and right here in between 4 and 2, then we will have the values of array A are the same, and that is 2. To get that, we have to done 2 rotation. So for this given array, we have to return 2. Where we're returning to, because we have to made 2 rotation so that the values of array A are the same and the value is 2. So for this given two array A and B, we have to return 2. If we are given A equals to this array, B equals to this array, and they are represented like this. This is a tiles that contains two numbers, top and bottom, top number 3 and bottom number also 3. Now our goal is to do minimum rotation such that the values of A are the same or the values of B are the same. For this two array, there are no such rotation on which we can have the values of A are the same or the values of B are the same. So for this two array, we have to return -1. Now let's see how we can solve this problem. Let's suppose that we're given this array A and B, and they are represented like this, and we have value from 1 to 6. In the given array, we have value from 1 to 6. For 1, 2, 3, 4, 5 and 6, we'll iterate through the two array from left to right at the same time. When we have value equals to 1, then our goal is to find out the minimum number of rotation that we can make to array A and array B such that they contain all value 1 and there is no such rotation we can make. So in this case, for 1 we'll return -1 because there is no minimum rotation we can make. Then for value 2, now our goal is to find out the minimum rotation we can make to array A and array B such that they contain the value 2. In this array A, if we do rotation here and if we do rotation here, then we will have all the value 2 to this array A, and there is no such rotation we can have for array B such that we can have all the values are 2. So we can have the value 2 for array A, so we'll return 2 for 2. Now we have value 3. Now we have value 3. For value 3, what we're going to do is that we're going to find out the minimum rotation in between array A and B such that array A contains all the values 3 and array B contains all the value 3. And there is no such rotation we can make to array A and array B. so we have to return -1 for 3. Then for 4, now our goal is to make rotation in between A and B such that the array A contains all the value R4 and the array B contains all the value 4, and there is no such rotation we can make. So let's return -1. For 5, let's find out the minimum number of rotation we can make such that array A contains all the value 5 and array B contains all the value 5, and there is no such rotation. So let's return -1 for 5. Now we have 6. For 6, let's find out the minimum number of rotation we can make to array A and to array B such that they contain all the value 6, and there are no such rotation we can make such that array A or array B contains the value 6. So we have to return -1 for 6 as well. Okay, we're done. And here our goal is to find the minimum positive integer, and we have minimum positive integer 2. So 2 is our answer. And this is how we can solve this problem. The solution will take bigger of 6 times n time complexity, where n is the length of the given array. Here 6 is a constant, so we can remove constant from our complexity analysis. So this solution will take bigger of n time complexity and will not use any additional space, will have some variable. So the solution will take constant space complexity. For better understanding, let's take another example. If we have this two array A and B, they represented like this, and here we have value 1 2 3 4 5 6. First we have value 1. For value 1, we're going to find out the minimum number of rotation we can make in between A and B such that all the value in the array A are 1 or all the value in the array B are 1, and there are no such rotation, so we'll return -1. And for 2, and there are no minimum number of rotation, then we can have all the value 2 for array A or for array B, so it will return -1, and it's 2 also for the rest. So we see that for the two given array, there is no minimum rotation such that the array A contains all the value at the same, or array B contains the same value. Okay, for this two given array we have to return -1. Now let's see how we can solve this problem. For sake of understanding, we assume we have these two array A and B. First, we're going to declare a function min rotation that takes A and B to array. Then we're going to declare a function answer equals to -1, and this answer variable will store our answer. Then we're going to run a loop for val from 1 to 6. We're going to iterate through the array from left to right at the same time for each number from 1 to 6. Then we're going to call a helper function, and the helper function will return the minimum number of rotation such that array A or array B contains the same value. If there are no such rotation, then it will return -1. Okay, then here we will check if current answer is not equals to -1 and answer not equals to -1, or answer is greater than current answer. Then we will change the value for our answer variable. At the end we will return answer. Now let's see our helper function. This helper function takes 3 arguments, 2 array and 1 value. Then we're going to declare 2 variable, answer top equals to 0 and answer bottom equals to 0. Answer top for array A and answer bottom for array B. For I from 0 to length of the array -1, since the length of the array are same, so we can use A or B, it doesn't matter. Here we're iterating through the array from left to right at the same time. Then we're gonna check if the value does not exist in the tile, then we'll return -1. If we see the value exists in the domino, then we will check if the value do not exist on the first array, then we will increase answer top by 1. If we see the value does not exist in the second array, that means in the array B, then we will increase answer bottom by 1. Okay, at the end of the for loop, we will have the minimum number of rotation we can make in between the two array, and we will return the minimum of answer top and answer bottom. And this is the pseudocode for this problem. And this is not that much difficult. If you go through with your 1 or 2 examples, then you will see how logical it is. And for this two given array, there are no such rotation we can make such that the array A will contain the same value or the array B will contain the same value. So we have to return -1 for this given two array. Alright guys, this is my solution to this problem. If you aren't understanding this video explanation, don't worry. Go through this pseudocode with your own examples. Use 2 or 3 examples to understand this problem, then it will make sense. I hope you have understood this problem. And this solution will take big O of 6 n time complexity, that's equivalent to big O of n, and it will take constant space complexity. Alright guys, this is my solution to this problem. Thanks for watching this video. I will see you in the next video. Till then, take care.